So in a traditional physics class, before you talk about energy, before you talk about momentum, before you even talk about forces, um, the first thing that they do right after you do cover vectors is projectile motion, which we're covering at almost the end of the class, or at least at the end of the required material. And I kind of like the fact that your book does it this way, because now when we look at projectile motion, we're going to understand all of the principles behind what's actually happening, right? So imagine if we're going to fire something in the air, okay? And the reason we call it a projectile is it's something that isn't going to have any acceleration after we launch it. So something like a bullet or a cannonball or a rock out of a slingshot, or just anything that's not going to have any like engines or anything to propel it after it's initially launched. Okay, so we're going to launch it with some initial speed v0. Okay, and our velocity is going to be, making some angle theta with the horizontal, for example. Okay, so we know that the only acceleration is due to gravity, and it's minus g. So that tells us that the velocity, which is the integral of the acceleration with respect to time, is just going to be v0x in the x direction and v0y minus gt in the y direction. And then our position is the integral of v dt, which is going to be x0 plus v0x times t in the x direction, and y0 plus v0y times t minus 1/2 gt squared in the y direction, right? And everything that we do with projectile motion is going to involve these three equations. Okay? So notice that when we launch our particle, it'll follow some kind of track that looks something like this. It's going to be somewhat parabolic. And the reason is because in the x direction we have it linear, so it's moving linear in one direction. And we have a squared term in the y direction. So we're going to see it arc something like that. Now if we make it a little bit sharper, well, that's a bit too sharp, but if we make it, a little bit sharper, we would notice that it might go a little higher, but it's not going to go as far. We could make it a little shallower, and again, it would not go as high, and probably not as far, depending on how shallow and how long we make it. So there's certain ideal angles, and in a lot of physics classes you would solve for those. I think your book might even have you find what the optimal angle is if you neglect air resistance. But this is really what projectile motion is we're just trying to find out some kind of motion between a particle between two different places, and we're trying to describe its motion.